Okay, so great. I welcome you once again. We are still on the concept of circle geometry. Yes, previously we were looking at the first three theorems I gave. I gave eight theorems as long as circle geometry is concerned. So we shall be looking at all these eight, as I said, that we shall take them one after the other. So today we are going to look at the fourth one. All right, yes, but before that, let me introduce myself once again. My name is Evans. I'm still your mathematics facilitator. The name of this channel is Mazris TV. Kindly subscribe to my YouTube channel, like and share the videos as well. You can also get Mazris TV on TikTok. All right, so let's quickly look at the fourth theorem of this concept. Okay, so for the fourth one, we have what we call what a cyclic quadrilateral. Yes, so when we talk of a quadrilateral, we all know that we are dealing with what a four-sided figure or a plane figure with four sides. All right, yes, and we have different kinds of what quadrilaterals. We can talk of a square, a rectangle, can also talk of a trapezium, kite, and all that. We have different types of quadrilateral. Okay, all these types can be cyclic. Okay, but when we say a cyclic quadrilateral, what are we trying to say? So for this fourth theorem, we are saying that it illustrates a quadrilateral inscribed in a circle. So when we talk of a cyclic quadrilateral, we mean a quadrilateral which is inscribed in a circle. And when we say it is inscribed in a circle, that is when the vertices of that quadrilateral lie on the circumference of a circle. All right, yes. So if you draw a quadrilateral in a circle, the moment you realize that all the vertices lie on the circumference of a circle, then it qualifies to be what a cyclic quadrilateral. And what does this theorem say? What does it say at all? So for this theorem, we are saying that the opposite angles are supplementary. Yes, so when you take the quadrilateral, which is inscribed in a circle, the opposite angles add up to what 180 degrees. That is what we are talking about. That is what this theorem talks about. All right, just if that's the case, let's look at how these diagrams look. Okay, yeah, so we can have can draw our circle and identify the center and name it O. So let's draw this quadrilateral, or let's do the inscribed quadrilateral in the circle. Yeah, so we have this quadrilateral in the circle, then we can identify the angles. Okay, that is M, N, P, and Q. So the theorem is saying that opposite angles sum up to what 180. It means that M is opposite to N, P is opposite to Q. Then M plus N should be equal to 180, and P plus Q should also be 180 degrees. Let's look at another diagram. Okay, yes, so for this one as well, we can look at this diagram and have this quadrilateral. Let's identify the angles. So A is also opposite to C, B is opposite to D. If that's the case, then A plus C is equal to 180 degrees and B plus D is equal to 180 degrees. Good. Now let's look at this question. So we are to find the values of for T and R. So we apply that principle, the theorem. If that's the case, then T is opposite to 52 and R is opposite to 110 degrees. If that's the case, then to find T plus 52 degrees is equal to 180. Then we group like terms and then we find T to be what? 128 degrees. And we do the same to R. R also becomes R plus 110 degrees is equal to 180 degrees. And then R is giving us 70 degrees. That is a cyclic quadrilateral. Very interesting, right? If that's the case, then let's go back to our software GeoGebra. Okay, Okay, so yes, this is our GeoGebra software. Okay, so as we have been using previously, now let's okay, let's clear the this region. Okay, let's clear the and then we come here as well, we clear all this here so that we have a blank space. Yeah, so we are going to draw a cyclic quadrilateral. So the GeoGebra software is going to help us to show indeed that opposite angles sum up to 180 degrees. So what I will do is, first of all, I will choose my circle. I will come here, select a circle with center through point. Then I will just drag it like this. I will drag it to any convenience diagram I like this. Yes, and then drop it. Good. So we have this diagram. Now I want to move the circle to, yes, I want to move it. So I'll come here, then move the circle. I want to move it here a bit, so I'm bringing it here a bit. Okay, yes, so good. Now what are you going to do? Because we are we want to get the, what do you call it, quadrilateral. Then what I will do is I'll come here and choose what polygon, because this is polygon that we can get four-sided figure. So I'll choose polygon. Then I can draw any shape. I'll start from here, click here, and then move it here to draw a line here like this. Okay, then I'll move here, yes, and then I will drop it here, come here and draw another one like this, and then I will join it together. Then I have my quadrilateral inscribed in a circle like that. So I want to get the angles. Okay, I want to know whether indeed, so I will come here. Okay, yes, then I'll select angle. So I want to get angle at this point. There I'll click here, or I'll move to this angle. I want to get the one at D. Then I will come here again to clockwise or anti-clockwise direction. Good. So as soon as I click E, I have that angle. Now I want to get the one at E. So I'll come to D. Okay. Click on D. Click on E again. Then come to F and click F. And then I've gotten the angle at what? E. Then I want to get the one at F. So I will come to E, click E, then click what? F, then move to C, and I have that as well. I want to get the one at C, so I will come to F, click C, and then click what? D, so that I have all the angles. Yes, very basic. So you see that we have the angles. Now let me try and move each of the angles so that we can see them clear. So I have this angle here, that is 86.27, and I have this one here which is 90.94. then I have this 93.73, and then I have 89.06. So you can do your calculation. Okay, we can take the opposite ones, C and E. That's 89.06 plus 90.94. You realize that when you do your calculation, you add them, you get 180, as well as the same as what? 86.27 plus 93 plus 73. You realize that you get 180. So GeoGebra has helped us to prove indeed a cyclic quadrilateral. Opposite angles of the quadrilateral, the sum of opposite angles of the quadrilateral are equal to what? 180 degrees. So if that's the case, then this brings us to the end of today's lesson. Okay, so in our next video we are going to continue with the rest of the theorems. If that's the case, let's end here. My name is Evans. I'm your mathematics facilitator. This is MathsBiz TV. Kindly subscribe, like, and share the videos.